Hello everybody, this is our matrix operations video for Unit 8. It's number 3. So make sure you've got a calculator with you. You can use whatever calculator you want because we don't need the graphing calculator features on this part. And we're going to be working here on some basic operations. We're going to work with addition, subtraction, and also some scalar multiplication, and I'll explain what that is as we go. Alright, so adding and subtracting matrices, we have to start with the fact that they must be matrix of the same dimensions. So they have to have the same number of rows and the same number of columns, or we won't be able to add them together. So what we do is we're going to basically follow the operation that's indicated in this first problem. We have addition by adding the elements, the coordinating elements or corresponding elements together. So for this first one, I'm going to add the 2 plus the 9 to give me 11. And then I will add 7 plus negative 8 to give me negative 1. Negative 3 plus 0 is negative 3, and 5 plus negative 1 is 4. And this is the resulting matrix of adding those first two together. For our second problem here, we're going to be using subtraction. We're going to be subtracting the corresponding elements, being very careful with our negatives. Okay, so if you have a calculator, if you want to try that without a calculator, go right ahead. And I've got 11.2 minus a negative 5.6, which will give me, I'm going to have to write it here, this is going to give me a 16.8. Okay, and then I'm going to have 4.8 minus 2.0, so 2.8. And then a negative 3.4 minus 1.1 is negative 4.5. So we are just matching the corresponding and following the operation that we were told to use. Now if I look here at the last example, I see that this matrix has 1 row and 2 columns, and this matrix on the second matrix here has 2 rows and 1 column. Because these matrices are not of the same dimension, it's not possible to add them, and we would just simply write that it is not possible. I wouldn't write no solution because I'm not solving for an unknown, so the correct answer is not possible. Alright, so then here comes a situation where I've got some variables, and now we're going to be adding the expressions that are within those elements. So for the first element in my matrix, I've got 2 plus x plus 4x, or 2 plus 5x, and you may write that as 5x plus 2. That's fine. The next one is going to be 3 plus y, and simply written 3 plus y, and you may write y plus 3. In the next one, I've got 2x plus 5 and x minus 1, or 3x plus 4. And lastly, we've got y minus 7 plus a negative 3, or y minus 10. You need to make sure that it's very clear to whoever's reading your matrix, another person in the classroom, perhaps your teacher, that these are spaced appropriately, that they actually look like different elements and that nothing's blurring together. So don't try to write this in the tiniest space possible. Make sure it's very clear to whoever's reading and assessing your work. Let's take a look at the next one, which is subtraction with variables. Here I've got m plus 3 minus m, and I need to be very careful with that subtraction. So when I do m plus 3 minus m, I just get 3. Then I have 2m minus 4m, or negative 2m. On this one, I'm going to have n minus 1 minus m minus 1. And I chose to put it in parentheses because I'm actually subtracting the entire expression, so I need to be able to distribute that negative appropriately. So I have here n minus 1 minus m plus 1 when I distribute the negative, giving me n minus m. And lastly, I've got 3n plus 4 minus 2, or 3n plus 2 to finish that. All right, now we're going to move on to something called scalar multiplication. A scalar is it's a number. It's I can use the word the magnitude, that it actually will double, triple, halve something. It's a multiplier on the entire quantity that we're looking at. So we will be using distribution here. So I will merely be distributing the 3 to all elements inside of our matrix. So by multiplying, 3 times 4 is 12, 3 times negative 2 is negative 6, 3 times 1.1 is 3.3, and 3 times 5 is 15. This is a use of scalar multiplication. Okay, for this next example, I'm going to be multiplying 1/2 times all of the elements in the matrix. That will give me 1/2 times 6 is 3, 1/2 times a third is 1/6, and 1/2 times -4 is -2. For this final example on our scalar multiplication, I'm going to be distributing the -2 to each of those expressions within the matrix. Let's go ahead and do that. That gives me -2x, and I'm going to have -2x minus 2. The next one's going to be -4x, and then -8. Again, make sure your expressions are far enough apart that these -2x and the negative that doesn't blend in with the element that is next to it in the same row. So make sure they're spaced out appropriately and they're very clear to read. All right, and the last thing we're going to look at here is what if I combine those possibilities. So here I'm just doing a combination of operations where I will use scalar multiplication and addition or subtraction. And I could make these problems as big as we want. We can even use variables, and you will see those variables in your assignment that follows this. So if I go ahead and I'm going to start using order of operations, which means I have to do multiplication before I do addition. And so I'm going to go ahead and distribute, and I will have 3, 12, 33, and -6. I will add the elements of this matrix to the other matrix, and that's making sure we follow the order of operations. For a final result of 10, 14, 28, and -5. Okay, go ahead and let's try this next one. I'm going to distribute the -2 following the order of operations. If you'd like, you may also distribute a -1 to the second. All right, so I'm just going to go ahead and use subtraction, but you are welcome to distribute a -1, and then you're just left to add those together. And then I have a resulting matrix of -6 minus a -3 is -3, -8 minus 1 is -9, -10 minus 2 is -12, and 4 minus 0 is 4. And this is the resulting matrix. Okay, to finish this up, you're going to try page 552, numbers 21 to 27 odd, 35, 37, 41, and 43. Some of those involve some variables, and others are very quick at adding, subtracting, and using scalar multiplication. You'll also be trying entrance slip 3, and we'll talk about the rest when we see you in class.